Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today, for exam P on probability. Let x be a random variable representing the number of times you need to roll, including the last roll, a fair six-sided dice until you get 4 consecutive sixes. Find E of x. By the way, you can find a complete review and discussion of this problem with several, not just one, several methods of solving it using different approaches in this paper by Roger Eggleton and myself, the 6666 problem in the Mathematical Gazette, volume 96, number 535, published in March 2012, on pages 39-48. And here's the solution. So note that the random variable that we're studying, x, is greater than or equal to 4 with probability 1. Also, if x is equal to n, for n greater than or equal to 5, then the last 4 rolls are sixes, but one just before was not a 6, and there were no 4 consecutive sixes on the n minus 5 rolls before that, because we're looking for 4 consecutive sixes, not 4 sixes. So this is not a simple negative binomial question. This is very different. So for n greater than or equal to 5, probability that x is n is equal to 1/6 to the 4, that's 4 sixes, each happening with probability of 1/6, times probability of getting not a 6, which is 5/6, times probability that x is greater than n minus 5, which is 1/6 to the 4th times 5/6 times probability that x is greater than or equal to n minus 4. This means that for n greater than or equal to 5, probability that x is equal to n plus 4, so we replace n there with n plus 4, is equal to 1/6 to the 4th times 5/6 times probability that x is greater than or equal to n, or equivalently that probability that x is greater than or equal to n is 6/5 times 6 to the 4th times probability that x is equal to n plus 4. Or you can just write this also as 6 to the 5th/5 times probability that x is equal to n plus 4. Okay, but remember, we said that probability that x is greater than or equal to 4 that's event that x is greater than or equal to 4. This happens with probability 1, and observe that probability that x is equal to 4 is 1/6 to the 4th, which is 6 on rolls numbered 1, 2, 3, 4. Probability that x is equal to 5 is 5/6, so it's not a 6 on the first roll, times 1/6 to the 4th. Probability that x is 6 is 1, which is any probability of having any number on the first roll, times 5/6, which is probability of getting not a 6 on the second roll, times 1/6 to the 4th, which is probability of getting 6 on rolls numbered 3, 4, 5, and 6. And probability that x is equal to 7 is 1, any number on the first roll, times 1, probability of any number on the second roll, times 5/6, not a 6 on the third roll, times 1/6 to the 4th, which is probability of getting 6 on rolls numbered 4, 5, 6, and 7. And we know from our friend Darth Vader that for a discrete random variable x whose only possible values are positive integers, e of x is equal to sum from n equal to 1 to plus infinity of the probability that x is greater than or equal to n. So by applying this formula to x in this problem, we get this. We get that e of x is equal to probability sum of the properties from n equal 1 to plus infinity of the property of x greater than or equal to n. And again, this is just a version of the Darth Vader rule as applied to a random variable whose only possible values are 1, 2, 3, 4, and so on. And that's equal to the sum from n equal to 1 to 3 of probability that x is greater than or equal to n, plus the sum of the probabilities from n equal to 4 to plus infinity of the probabilities that x is greater than or equal to n. And of course, for n equal to 1 to 3, it is certain that n will be greater than or equal to, that x will be greater than or equal to n, so that's 1. And then plus, and we can write this as the sum from n equal to 8 to plus infinity of the probability that x is greater than or equal to n minus 4, because we simply replace n by n minus 4 and start the count from 8. And that's equal to 3 plus the sum from n equal to 8 to plus infinity of 6/5 times 6 to the 4th times probability that x is equal to n. And that's 3 plus 6 to the 5th over 5 times the sum from n equal to 8 to plus infinity of probability that x is equal to n, which we can replace this expression in parentheses by 1 minus the sum from n equal to 4 to plus infinity of the probability that x is equal to n. Of course, n can't be 3, 2, or 1 because you can't get 4 consecutive 6s by rolling dice only 1, 2, or 3 times, so those probabilities are 0, irrelevant. So it's just 1 minus the sum from n equal to 4 to 7 of the probability that x is n. And then we just have 3 plus 6 to the 5th over 5 times 1 minus 6 over 6 to the 5th minus 5 over 6 to the 5th minus 5 over 6 to the 5th minus 5 over 6 to the 5th. These are the calculations we did before. And that is then equal to 3 plus, and 6 to the 5th cancels in everything except the first expression. We would have to write, 1 would have to write as 6 to the 5th over 6 to the 5th. So this is 3 plus 6 to the 5th minus, then what do we have there? 5 plus 5 plus 5, 15, plus 6, 21. So 6 to the 5th minus 21 over 5, we just calculate that. That's 1,554. And that's answer C. And if you want to see other possible solutions, and look it up in that paper. But this is the most straightforward, in my opinion, which you need to understand, because this is the direct application of the Darth Vader rule for the discrete case, which in some form shows up on the test. This problem is maybe a bit harder than a typical problem on exam P, but very good for you. It's very healthy. Please remember, this is copyrighted material. The problem was created by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.